A very good afternoon to everyone. On behalf of Amity Institute of Food Technology, I welcome you all for e-workshop on innovation and sustainability in food processing. I would like to invite Dr. Monica Thakur from AIFT, Amity University for a welcome address. Over to you, ma'am. Thank you.
Thank you so much, Dr. Sunay. So good afternoon, one and all. A respected guest of honor, Professor Cravato, keynote speaker, Professor Ramantas, Honorable Vice Chancellor, Madam Dr. Balvinder Shukla, respected Dr. Silvamurthy, sir, Dr. Nutan Kaushik, ma'am, Head of the institution, Dr. V.K. Modi, dear faculty colleagues, and dear participants. We are happy to welcome you all to the 8-day workshop on innovations and sustainability in food processing. In this workshop, speakers from different continents will deliberate on various issues on innovations in food processing, food quality, instrumentation, and entrepreneurship opportunities. I hope all the participants take maximum benefit from the workshop. Certificates will be given to all the participants based upon their 90% attendance and assessment submitted. So once again, thank you all, and over to you, Dr. Sunay. Please.
Thank you, ma'am. Now invite Professor Dr. V.K. Modi, Head of Institute, Amity Institute of Food Technology, Amity University, Uttar Pradesh, to kindly introduce the theme of the workshop. Over to you, sir.
Okay, my dear dignitaries, distinguished guests, dear colleagues, participants, and students. First of all, it gives me a great pleasure to extend a very warm welcome personally and on behalf of Amity Institute of Food Technology to today's our guest of honor speakers, Professor Cravato, Professor Rimantas, and our respected Honorable Vice Chancellor, Madam Dr. Balvinder Shukla, Dr. Salva Murthy, Sir, President of Amity Science and Technology and Innovation Foundation, and Director General, Amity Directorate of Science and Innovation, Dr. Nutan Kaushik, Director General, Food and Agriculture Foundation. Today come to the today's theme of our workshop, innovation and sustainability in food processing. A few points are very essential to address in today's workshop. That foremost challenge is to look at the population to feed. A global population expected to reach 8.6 billion by 2030. Looking at this population, it becomes very important to consider how the supply of natural resources to be safeguarded and the livelihood of billions who work along the agriculture value chain to stay. Making our food system more sustainable will depend on innovative tools and approaches being developed and deployed around the world. Therefore, following approaches for sustainability to be at forefront in terms of economically, socially, and above all, environmentally. Economically sustainable means these innovations must provide income and create jobs. Socially sustainable means to reduce level of hunger and malnutrition. And third, which we cannot ignore at all, the environmentally sustainable means they must help us safeguard our natural resources, water, soil, and air quality while minimizing greenhouse gas emission and food losses and waste. Further, looking at sustainable food system are interconnected and represent the full agri value chain from pre-production and production to supply chain and consumption. So under pre-production, what we include is the first thing comes the genetic resources improvement, agriculture practices, and agricultural input in terms of fertilizers and agricultural implementations. Now, second part is the production, where we include the growing, harvesting, and food loss management. Being a food technologist in the post-harvest part, that food loss management becomes the a very crucial point here. Third point comes the supply chain, which include the processing, storage, transport, wholesale, wholesalings, retail, and then market access. Again, here processing in supply chain and storage that becomes as a food processing or food technology a very key factor. Third part is in our today's debate workshop will that is the consumption under the sustainability. That includes, of course, cooking, eating, and food waste management. That is the again very important factor. So the sustainability of food system begins well before a crop is grown. This pre-production stage not only includes to improve the quality and productivity, but also includes innovations in agricultural inputs. So under this, the solutions suggested here under pre-production are the development and maintenance of gene banks, support breeding efforts to develop best practices around fertilizer and water resources, and more productive seeds through biotechnology to be used for the benefit of all. Second part of sustainability is the production. Production stage where farmer faces the challenges involved not only in growing and harvesting, but also food loss and fluctuating marketing conditions. Therefore, range of production solutions to overcome the aforesaid challenges include how to reduce dangerous, for example, aflatoxins levels in groundnut especially and in maize, and judicious use of fertilizer, and to tap into available technologies and practices for adaptation. Third one is the supply chain. The chain refers to the steps taken to deliver food from the farmers to the consumer. Here the food products can be processed, packaged, and stored before eventually being transported to the market. So major rule after post-harvest technology or as a food processing or a food technology, that the real picture comes under the supply chain system. Post-harvest food losses is an especially important issue across the developing world, where the infrastructure and transport systems are often poor or missing, and an estimated 40% of food losses are during the transportation or storage or processing. That is what we call post-harvest losses. The best available solution to overcome this include solar power energy use, chiller or processing at farm level as far as possible. The last part of food sustainability is consumption. A food system does not only capture how something is grown, it also includes how a food is cooked, eaten, and disposed of by consumer. During this consumption stage, each of us make a series of decisions which have broadened applicable to our food and nutrition security. Now, what are the solutions? How to prepare, consume, and dispose of our food? All three factors are interlinked to sustainable food system. In last, let as we scientists, processor, or growers accept this challenge, as I highlighted under food sustainability, and through this workshop, we shall throw a light for better and healthy viable food system to feed the world. So with this, a, a, a brief theme of the workshop, I thank you very much for today's workshop and have a nice day. Thank you. Over to Dr. Monica.
I think, yes, Dr. Sunain, please.
Thank you, sir, and enlightening us about the brief introduction related to the sustainability and innovation in food processing. Moving ahead for today's inaugural session, now I would like to welcome Dr. Nutan Kaushik ma'am, Director General, Food and Agricultural Foundation, Amity University, Uttar Pradesh. Having an experience of 25 years, she had been actively involved in research on agriculture policy and planning. She has also developed a roadmap for agriculture in India for 2047 in Disha project. She has worked in several international universities as visiting scientist. We would like to hear from you, ma'am. Thank you. Over to you, ma'am.
Thank you, Dr. Modi, and thank you, Sunaina, for the invitation.
Thank you.
And, first of all, I would like to congratulate Dr. Modi for organizing this 5-day workshop, which is a very timely workshop. And the theme, particularly selecting the theme of the workshop, that is innovation and sustainability. So this is very apt subject, and which is very timely subject, because this is having achieved the food security from 50 million ton to more than 395 million ton. Now we are talking about, we have to ponder like what we are consuming. Are we consuming in the right manner, or are we consuming from the right sources? Are we leaving a footprint, carbon footprint, by consuming certain type of food or not? So this is the time when we think about the not only of the economic sustainability, the food sustainability, but also the environmental sustainability. Think about our planet. As Dr. Modi has rightly like told about the entire supply chain, right from the production up to the, like what we call it, a farm to plate. Like after the food is not complete unless you talk about the farm, and it is not complete unless you talk about the plate. So what are the different steps which are involved? He very well explained that what are the footprints, carbon footprints of the various stages, like transportation, like the inputs which we use during the production. I think 90%, you will be astonished to know that 90% of the water we consume is consumed only for the agriculture purpose. So if we can save this water, like by applying the drip irrigation or something like efficient use of the water, we can save more than 80% of the water. So net saving we can do by promoting such type of technologies. So water, like at one point of time, it was said that next world war will be on water, because water is such a scarce resource. So nobody is thinking about the increasing the efficiency in agriculture supply, because there it is one of the largest water consumer. Second thing, like the pesticides and all these things, we need the green solutions, not in the inputs. Then he talked about the transportation, he talked about the food loss. I'll just give you one example. Like there was a recent study in 2020 only, it has been in last year only, it was published, where they did this carbon footprint of the various food items for the entire, based on the entire value chain. Not, they didn't do the analysis only for the production. What is the footprint for the production? So they did the footprint only also for the production, for the transport, for the processing, for the retail, packaging, and up to the desk. So from farm to like the fork, the entire footprint was covered, and based on that, they have published this one, and based on that, our P comes the lowest footprint, with the lowest footprint. Rather, it is the positive in terms of the carbon footprints. So our food choices are equally important if we really want to help our environment. If we want to talk about the sustainability. Like similarly, so after that, there was bananas, fruits and vegetables, rice, which was little higher because we grow submerged rice. If we do not grow submerged rice, the footprint will be little lower. Now it has been proven that we can grow. There's no need of submerging the rice for cultivation. It has been proven now. It is a traditional way of doing this cultivation, but it has been proven that we can do by drip irrigation. We can cultivate the rice by drip irrigation. And it has been proven not only here, but in many countries it has been proven. So this is one thing. And secondly, we have to change the business as usual scenario if we really want to talk about the sustainability. So like something like high, if we produce, if we give the high yield varieties, we can reduce this carbon footprint by 13%. And if we give this, if we halve the food wastage, we can reduce the carbon footprint by 27%. Just by reducing, but just by focusing on the food wastage, our carbon footprint can be reduced by 27% in this entire food chain. Similarly, by healthy calories, by if we eat right, if we eat healthy calories, because calories come from different portions. So they are healthy calories, they are unhealthy calories. So if we if we take our healthy calories, we can reduce our carbon footprint by 30%. Best practices adopted by the farmers can reduce the farming by carbon footprint by 40%. Then plant-rich diet can reduce the carbon footprint by 48%. So we can, it's the choice is ours. So, so if we compliant all these practices, even if we do by 50%, the food footprint can be reduced to 50%, quite drastically. So, so the choice is entirely not only on the product, on the producer or the processors, but also on the consumer, because ultimately it is the consumer who is driving the market. If there is a demand, then that demand need to be filled up by the. So consumer choices is equally important in this sustainability term. So I would, so with these words, I think this conference will bring a lot of new deliberations, which will give a new direction in this area, because we have a lot of international speakers. We will come to know, we will listen to them, and we'll come to know what are the new innovations which are coming up to address this sustainability. Like, so with these words, I will once again congratulate Dr. Modi and his team, particularly known for Monica and Renu and all other colleagues. And I thank and with for and wish you a great success for this conference. Thank you.
Thank you, ma'am. Thank you for enlightening us and telling us the importance of choosing the right food and to conserve the water. Now I welcome Dr. Selvamoorthy Sir, President, Amity Science, Technology and Innovation Foundation, Amity University. Sir has been successfully and actively involved in promoting and coordinating research and innovation at Amity Universities. Over the experience of more than 40 years, Sir has been a member of various institutions of Government of India like DRDO, ICMR, to name some. Please, sir, enlighten us with your words. Thank you.
Thank you, Dr. Sharma. First of all, let me extend a very warm welcome to all the participants for this very important the webinar, the conference which Amity Institute of Food Technology is organizing today. I find a large number of experts like Professor Crebato from Italy, Professor Rimantas from Lithuania. We have experts from Iran, Turkey, Aligarh Muslim University in India, CFTRI, Central Food Technology Research Institute, Banaras Hindu University, and many, many more institutions. So first of all, I extend a warm welcome to all the speakers, plenary speakers, keynote address, and also the lecturers. I must also compliment Dr. V.K. Modi for this wonderful initiative he has taken to organize this workshop, which is going to deal with what are the important aspects with regard to innovation and sustainability in food processing. So that is the focal theme in which all of us are going to deliberate. And I must also compliment Dr. Nutan Kaushik for just giving her remarks as DG, and also looking after these institutes, Agriculture and Food Institute, very effectively. Founder President Dr. Ashok K. Chauhan has sent his greetings and best wishes, blessings for the successful outcome of this workshop. I'm sure we'll be expecting the outcome from all the deliberations. I also compliment the other people like Dr. Monica, Dr. Sunanya, Dr. Renu, Dr. Tanu, who is involved in organizing this event. My compliments to you. Now, if you look at India today, it is in the top 5 in the agricultural produce. A country 50 years ago or 60 years ago was a begging bowl. looking for food to come from another country to feed 30 crores of population at that time. Today we are self-sufficient in food, be it cereals, pulses, horticulture produce, and milk, fish, poultry, you name anything, we are on top five. The production is very good. So now the India, we are all scientists are focusing on food productivity, per hectare productivity. How do we expand? So when we are doing this, one major concern today in our country is post-harvest loss. Some of the produce, it has up to 30% post-harvest loss, and also the loss from the food waste. So all this is creating, disturbing and posing challenges for sustainability. And how do we bring innovation and sustainability in the food processing? Because food in the post-harvest, besides the other methods of storage, cold storage and others, the food processing is a very important value-added step for the agricultural produce to a value-added product. That is why the food processing is important. The food technologies are important. That is why Dr. Chauhan, Chancellor Dr. Atul Chauhan, started this great institution about 15 years ago. So the Amity Institute of Food Technology is looking into food processing, and in which we are now looking at in the change scenario, COVID-19, as well as the both the husband and wife employed, many the processed food will also become important, which is not being touched upon. So I thought I'll mention a few things on the processing of the food, like retard process, where you can have the shelf life of the products maybe up to 2 years. And also you can have meals ready to eat. You just don't have to process the food. You just warm it up and eat. So these kind of food is going to be very soon coming up, including functional food. So that is where the food processing industry, like MTR, Tasty Bites, Saras, Ashirvad, ITC, Nestle, everybody is focusing on now the processed food. So I think this is one area where Amity Institute of Food Technology is also focusing on this. So when we are considering this food processing, the industry is coming in a big way, expanding. Verticals are there in certain areas of food technology, and also we have horizontal spread of industries, food industries coming in. So here the challenge would be safety and standards. When you have so many new industries growing, so this will become a challenge. How do you maintain the right kind of standards and safety of the food in the food processing? So we have Government of India has established Food Safety and Standards Authority of India, FSSAI. So which is now giving the standards for food processing and all aspects of food safety. So which is now a very recent, it has become very powerful now, with food safety officers across the country being there. Then we are also looking at biopreservation. Instead of using the chemical preservatives, when you are looking at food processing, you are looking at the sustainable method, like biopreservatives. So these are all very new technologies, innovations coming in the food processing. I'm sure that whatever the outcome is going to be very valuable, not only to Amity University as a whole, but also to food processing industries across the globe. And I wish you all the best, and we will be eagerly looking forward to the outcome. A little bit about Amity University. Today we have 11 universities in India, 17 campuses abroad, 28 schools. We have 1,75,000 students, 10,000 faculties, 5,000 PhD scholars. It is a research and innovation driven university. We have published more than 25,000 research papers. We have filed more than 1,550 patents. So it's really growing as a research and innovation. So we will be looking forward to the partnership with all the experts who have joined us today, like Professor Prabotau and also Professor Rimatas and CFTRI. We already have an MOU with you. So we are going to have the chief scientist coming from there. So we would like to expand, deepen our relationship for a sustainable outcome and partnership. So with this, I wish this workshop a very, very great success in the years to come, and the fruitful outcome for everyone who is participating today. Best wishes. Thank you.
Thank you, sir. And thank you enlightening us with how that government of India has been doing and using various type of sustainable procedures in food safety. Moving ahead, it gives me an immense pleasure to welcome our guest of honor, Dr. Giancarlo Cravato, Professor for Organic Chemistry at University of Turin and Vice Director of the Department of Drug Science and Technology. His research activities is documented by about 445 scientific peer-reviewed papers, 20 patents, and several books as editors and chapters author. His main research interests are in the development of green and sustainable synthetic and extraction procedures. His studies have paved the road to innovative protocols for chemical process intensification, exploiting non-conventional techniques such as high-intensity ultrasound, hydrodynamic cavitation, microwaves.
Good afternoon, Dr. Das. Good afternoon.
Sorry, sir. Shall I continue?
Please, sorry.
Sorry. Okay. No problem, sir. High-intensity ultrasound, hydrodynamic cavitation, microwaves, flow chemistry, and ball milling. His research group have developed several hybrid chemical reactors combining different energy sources. He has collaborated with several industrial partners in the field of fine chemicals, plant extractions, petrochemicals, pharmaceutics, textiles, food processing, and cosmetics. He is the past president of European Society of Sonochemistry. He's been editor-in-chief of Processes, editor and editorial board member of various international journals, and he's been a member of Conseil Scientifique de l'Amour, Marcolle, France. He's been a visiting scientist at the Center of Bioanalytical Research and Molecular Design, Moscow State of Medical University. He's been a recipient of Gold Badge 2012 for his contribution to world science and international scientific collaboration. Also received a Scientific Research Award in 2018 for his work on organic chemistry for environment, energy, and nanosciences by Italian Chemical Society. Over to you, sir. Today he will be talking on new advances in food extraction and processing. Thank you, sir, for accepting our invitation and gracing our students with your presence. Thank you.
Thank you so much for your kind introduction. I really appreciate the overall introduction because all the words are really the key words. So I will skip some note at the beginning because really the introduction was exhaustive. So keeping highlighting all the main keywords in the field that are, of course, of interest for all the country. I will try now to share my screen. So, well, thanks again for the invitation. I really appreciate. Unfortunately, I hope that the pandemic will enable again to meet each other in your fantastic country. I visited several times. Well, I'm coming from the industry. I started my career in the pharmaceutical industry, and progressively in the year I moved to more and more in the field of food industry. And our experience is mainly in the process intensification. And you mentioned before, for instance, the shelf life of food, and then there are also some aspects that we were working a few years ago. So new advances in food extraction and processing, and I will start now to start with some analysis, state of the art. And as regards my country, the agri-food sector is Italy's biggest industry. So for Italy is extremely relevant also in the national GDP. And in general is a field that is growing also for the good reputation of the Mediterranean diets and also the quality of the production and the diversity. So all the regions in Italy have different products with peculiar quality, peculiar taste that make the difference. So I heard a lot about innovation, and really I think scientists, industry and producers in general have to a bit start to learn innovation learning, and of course everybody are looking for to think outside the box, to create a new opportunity, new aspect that can be exploited. So a good idea is not enough. So in general, in particular in research center, in academic, so a critical thinking is needed. And an idea move sometime to an invention, and it offers opportunity to design, and then of course after engineering, developing prototypes, but often it stops here in the middle. To really move to innovation is something more, because it's needed the commercialization. So innovation understanding is often a crucial point. So to think about that, even if we have repeated, we have the tradition in doing, in performing in such a specific way, but we can open the mind. So it's much more difficult to abandon old idea instead of accepting a new one. Another aspect that I'm really disappointed several times, that inadequate written research, in particular students are looking for publication, but there are also a lot of information from patents. So we have several examples of reinventing the wheel. And then it's unpleasant to highlight to colleagues that, well, okay, you are dealing about this topic, but be careful, a company 20, 30 years ago already was doing such process with adopting such a technology, but they could not, they didn't publish. So sometimes this is often in all the content. Another approach that is not common in the academia is to, if you imagine a new technology to moving ahead toward the industrialization, since the beginning, we have to put together marketing, proof of principle, and research development, all the competence, all the expertise, because then the probability to move ahead is much higher. So innovative technologies are fundamental, but innovation is strictly bound to market and business. So we cannot, as academics, say innovation thinking only a scientific publication. Definitely is extremely complex, the process. Innovation means complexity. I have many examples in which so a big ball, very heavy ball, stop to proceed. Sometimes also for bureaucracy, for many other difficulties that really hamper the progress. Another aspect is invention means something different to innovation. So as you can see here, magnificent invention, but now let's see. So sometimes invention are hardly to be applied. They can do for sure a specific process very well, but then because cost, because difficulty in management, so because there are many aspects that will stop immediately. So it remains an invention and not more. A very simple example for the student that, of course, the young generation, but well, our generation know well what happened. I was doing athletics when I was a student, and the meaning of innovation. So in Mexico '68, the English athlete Fosbury started to at the highest level the competition, because it was already a couple of years that people were trying this other way to jump instead of scissor or straddle style that was very common in that time. And in only 2 years, the old way to compete was abandoned just because the innovation in technique was much more efficient. I will not to be boring, but just only a couple of examples, a meaning of innovation in sailing. So you can imagine here now, you see that the boat are flying on the water. So this is also a tremendous impact in innovation that was observed in the last years. As Italian, let me describe one little object to prepare coffee, to prepare the Italian coffee, the mocha pot. In 1933, Mr. Bialetti patented a very little tool, very cheap, made in aluminum, but very efficient to produce a fantastic coffee. You know, we are good consumer of coffee. Well, a little tool producing million and million of course, of devices, they spread all around the world because it was cheaper, very cheap, and very efficient. Well, nowadays, the new economy, of course, is based on creative economy and creative industry. So we have to think today what could be new tomorrow and every day. And if you check an international ranking that was published by the European Commission, you see South Korea, United States, and Japan in the top. But well, we are also, as a European, and also Russia, China, Brazil, India, in the group of the top international innovators. We are really plenty of knowledge. Now, today we are dealing on food. I'm not expert in agriculture, but well, I'm much more expert in process intensification, new technology, also to guarantee shelf life, longer shelf life of product, or the way to transform and to exploit, maximize the exploitation of the food and avoid waste production. But often, and more now, we need to work in team with a different mentality, the so-called transdisciplinary, to merge different expertise and avoid to work separately, but to work really merging intimately our experiences, because it's much more effective. So a chemist that is thinking as also a biologist or a mathematician or a physics or an engineer or a medical doctor that put together an open mind to reach new ambitious goals. Unfortunately, we do not have this machine, knowledge transfer machine. And this would be really fundamental because often it's difficult to understand the advantage that new technology can offer. So the biggest problem nowadays is communication. We have to communicate much better and keep together people from different countries, from different expertise, because only with a good communication, we can also convince the consumer. So the technology preserve the tradition. In Italy, people are crazy about tradition. Well, tradition has to can be preserved with a good communication, and definitely bridging the gap between producer, industry, and academia. As I told you before, I'm coming from pharmaceutical industry, but in the last 10 years, I was much more involved with the collaboration with food industry. And now we see a lot of opportunity created by the growing convergence of food and pharmaceutical in the new area of nutraceuticals, cosmeceuticals, and so on. New technology, and so thanks to my experience in pharma industry, I was really impressed by some comparison pharma and food industry. And well, let me present here what the Wall Street Journal was publishing almost 20 years ago. So the pharmaceutical industry lags behind potato chips and laundry detergent makers in the use of modern manufacturing systems. Unbelievable. And the prescription for drug makers was, please update the plans. And much more recently, a work done commissioned by the Food and Drug Administration showed that pharmaceutical industry wastes $50 billion a year due to inefficient manufacturing. This is impressive. Well, this concept and this fact have to be also considered for food production chain. And Europe invested a lot in so-called CATs, key enabling technologies, that are fundamental to improve the sustainability, to save energy, that is another important point, and to reduce, of course, emissions. We work with several different technologies, and we are passionate of process intensification in different steps, considered to improve mass transfer, heat transfer, mixing, solubility, crystallization, and to achieve cleaner processes and also sustainable protocols in extraction and also in food processing. We cannot ignore, I really would like to highlight today, the circular economy, another key word that we have to consider in contrast, of course, to take, make, and dispose. And this is a priority in Europe, definitively. So a big effort has been paid to consider the sustainability in terms of circular economy and in the recycling. Natural sources are enormous, and besides the traditional applications, we can have a huge amount of byproducts from food industry. And we were working with a big company that produce frozen vegetables, and we see that with some vegetables, we have an enormous amount of clean waste, so-called waste, that could be easily used thanks to some technology. Well, in this way, we could really design new processes in which, beside the traditional application, we can produce food supplement, pharmaceuticals, products for animal feeding, and also to produce, considering cellulose and lignin, all this work in the conversion of biomass either in energy or in platform chemicals, so new product or new materials. We also work a lot in applying microwaves, ball milling, hydrodynamic cavitation, ultrasonics, to convert biomass in valuable product. And this is not an easy task, really an extremely challenging work to exploit the aromatic chemistry from lignin and all the chemistry of cellulose and hemicellulose to get new product or even new material, new polymers. Rapidly, I will show you, considering the time allocated, I will focus on few things, starting from solid-solid separation. There are available techniques when you have biomass from several sources, and biomass still has different components, but this component can be relatively easily at the dry level without any addition of water or other solvents at the beginning. This is a big energy saving, and there are several applications and plants applied in Europe, in Africa, in which you can see here the whole wheat flour and the whole meal flour, the physical separation, still to what was considered only for feed animals, could be still efficiently separed thanks to cyclones that can, when balanced, can exploit the different behavior in the air of different components. If the components are more rich in fat or in protein or in fiber, you can have a quite efficient enrichment of one of the more valuable fractions. Process intensification in plant extraction is extremely important because we have big sources of drugs, of nutrients, of nutraceutical in plant, but then we have to consider an efficient process to get target molecules and then we have to move from unit operation to a complete plant, industrial plant, to have an efficient, sustainable in terms of economic aspect and in terms of environmental aspect. So the real cost in the extraction often is not the cost of the plant, but is the cost of ethanol. So progressively, people are looking for alternatives because ethanol is too expensive beside the risk of flammability. So technology to go to open the, at least to create possibility on the cell wall, cell membrane to increase the process of extraction and to solvate the cytoplasm and then getting back thanks to the action of ultrasound or hydrodynamic cavitation or some high shear mixer that break the cell wall and you can easily get from the plant. And to accelerate the process, mechanical stress, turbo extraction, cryo-milling, the use of enzyme as well. Enzymes are excellent on this application, or PEF, pulsed electric field. All are going in the same direction. So we have now in our hand several technologies. Some of them are typically applied at a little level. Other can be applied in ton scale when applied in flow mode. Then other liquid, how we can replace organic solvents to respect the principle of green extraction that we published almost 10 years ago and now are known to everybody. We are working a lot now with the subcritical water. So water that at 150 degrees, more or less, the dielectrical properties also are comparable to ethanol in a way that we can skip the use of organic solvent. Other pressurized liquid, supercritical fluid, supercritical CO2, but also fluorohydrocarbons, mainly for other application instead of application in food industry. But well, we have an enormous portfolio, big scenarios in which all this technology can help. Does it make sense make a comparison? No, we cannot compare different technique applied at different conditions. So if we see here, so the hunting leopard will surely be the fastest in a stadium, but well, what happened in a swamp in water? Perhaps the hippo will be the fastest. So each technology has to be applied in the best own condition. If I'm heating with microwaves, so the heating is clearly needed. If I'm working with ultrasonics, I can work in flow at room temperature. So we cannot make a comparison. The comparison needs a life cycle assessment and to say, I am saving energy, time, and the quality of my product is superior. In technology, in food, microwaves have microwave and radio frequencies have a big, enormous application since years to dry. In Italy, it's more than 20 years that company dries spaghetti. So with the microwaves, very efficient. And of course, we can do fantastic extraction extraction directly in oils or in other medium. So microwave and other thermal, non-thermal technology have been reported in several books. This is a recent book we published last year. Microwave is one of the top 10 technology of the last century. So it's an impressive technology. You see here the first oven developed in the United States. It was 300 kilograms, almost 2 meters high. Well, it was the start, but then in 1967 in US, it was the first counterpart available in the market, relatively cheap, and then it was spread all around the world. The advantage of microwave is the extremely efficient dielectric heating, that is a volumetric heating instead of conductive heating. So you have in the conductive heating a gradient from the surface. Different with microwave, you heat directly the bulk. There are several equipment. This is a picture in our lab, and many applications apply with microwave to concentrate aromas, to condense fantastic essential oil that can be used for flavoring and so on. This is scaling up, where this is my PhD student applying microwave. It's like a wash machine in different size, both for extraction as well as for hydrodistillation assisted by microwaves. I myself here closing this is like a wash machine. As you can see here, I like to play with these tools, and as you can see, several applications, as I said, for extraction and for hydrodistillation under vacuum. The scenarios in food industry is, of course, enormous. We have several big plants for sterilization, for cooking, for defrosting, the defrost of meat. In Europe, a lot of meat, and we are speaking about non-sustainable food in the food chain, because of course cows generate a big environmental impact. But well, from Brazil, from Argentina, a lot of meat is coming frozen in Europe, and then the defrosting microwave is the most efficient. And in particular, the food heated in microwave is a food in which you can much better guarantee the microbiological safety. Drying is excellent. Well, let me go ahead because time is running fast with ultrasonics. We have more than 20 years of experience with ultrasonic. We have plenty of different types of equipment, starting, as you can see, in laboratory scale, and then in bigger scale. We have no limit in industrial application. You see here a 4-meter long horn that can be used for processing, and you can see here how it works rapidly, the action of the ultrasonics that destroy very rapidly our aluminum foil. So the cavitation, the implosion of the bubble, is doing the same effect on plant material, so the extraction kinetic is much, much faster. We have two methods. We build also by ourselves equipment with, of course, our technician, our engineers, using both piezoelectric system, much more common. All the baths in the lab are with piezoelectric rings, or for bigger scale with the magnetostrictive concept, in which the magnetostrictive alloy enable this, so the heart of the ultrasonic pulsing. So of course normally it's 20, 30 kilohertz, means 20,000 times per second. Here you have the whole effect of ultrasonics, and of course also some chemicals. So the use of ultrasound, or in any case different type of cavitation on food, have to preserve also some chemical damage, some radical production. This means that currently the action of ultrasonics for extraction is much shorter, with a much higher energy density. This is explaining the reason to moving flow. Coalescence of droplet is also here another aspect in which standing waves can enable to keep the oil out from water, because the droplets that can merge each other, and then the separation is much simpler. Other device in lab scale with some movement to enable a very efficient extraction process, and also here, as you can see, a multi-horn to work in flow. All the processes are controlled, like in a pharma industry, monitored with computer, and all the parameters are optimized and can be easily reproduced. We designed several applications, also in very big scale, and this is another book, a recent book, that design and optimization of innovative food processing technique assisted by ultrasonics. Ultrasonic can operate at different levels. From, you see here on the right, how ultrasound can break the foam. Is a plant for, that can be beer, Coca-Cola, what else, to close, you see, to close the can without the trouble of the foam. These are also applied for fermentation. You see, often we have yeast that produce a lot of foam, and the foam can be rapidly destroyed with these dishes very efficiently in less than 1 second. Cutting, the best way to cut food and without any risk of contamination is ultrasonics. This application is fantastic, is rapid. You can cut any kind of food and you avoid the risk, because in the surface of the cutting ultrasonic device, you cannot have the growth of bacteria or fungi or any other microorganism. So, well, Packaging is the most relevant, most important way to preserve the quality of food. And the closure, so the welding and the sealing of packaging now is very, very common with the use of ultrasound. And you avoid that to damage, because the heat, if you close by heating system, of course, this heat will not help in this case, is the use of enclosing packaging with a salad. New polymer, we have no time to go ahead, but ultrasonic be applied. These are biopolymer that we produce in our lab. Of course, it could be transparent. This transparent polymer was prepared from caseinate, some derivative from milk, calcium caseinate, actually cross-linked with glycerol to produce nice film for packaging, natural, and also using some clean waste. Of course, are not transparent, as you can see on the right, but the film is fine itself. Of course, if you have not pure product, you cannot have such a transparent disc. But the efficiency of ultrasound is that you are doing degassing. So you can degas, and so you have a very transparent layer. Homogenization. Clearly, this is one of the most common use. Also at industrial level, you can make a very, very fine emulsion. In particular, when you move from lower frequencies, and then when you obtain like a milk, then you can go in a higher frequencies in a way that the bubbles that collapse should more or less be of the same dimension of the droplet, in this case of an oil that has to be dispersed in the liquid. So this is a way to have very stable emulsion. This is an old patent of an ultrasonic homogenizer resonant chamber with this vibrating reed, as you can see, apply in preparing such emulsion that contain fat, so hydrophilic and lipophilic component in a very efficient way to have a very, very fine dispersion, stable in the time. So ultrasonic emulsification is an important goal, and it can be easily applied at any level and at any depth. Also in flow. This is another tool that we developed last year to improve the production of extra virgin olive oil, in which the only one step that is in batch, all the other are in flow, but the malaxing require for big producer several malaxers because it takes a couple of hours turning. So we skip the malaxer, we apply this device, one or more device, like in which the olive, crushed olive, are subjected to ultrasound with thousands of millions of holes, and you increase the productivity of oil, and the oil contains much more polyphenols. So the oil, it becomes a nutraceutical because oleuropein, hydroxytyrosol, oleocanthal can be included. You see here the connection at the industrial level, and also here how it works with the direct passage of the crushed olive, then directly, as you can see, to the decanter, separation, first the decanter, and in a second step, the separator to get oil and water. So, well, just few slides of industrial application of ultrasonics, case by case, it depends on the application. You have to design the equipment on the base of your need. So you cannot use one equipment for each application. These are the most standard, traditional equipment for extraction. Is a company close to Turin. You see here in the middle, the fore and the propeller in the middle, so the steerer, the mechanical steerer, because the penetration depth of ultrasonics is only a few centimeters. So the point that this type of device is now, I would say, obsolete. So it was the old way to extract. People that have company that have this device are going on, but nowadays there are much other opportunity. This is a photos with a 3 kilowatt system. This is my former PhD, now is a postdoc that is working with the 2 units. You see the plant material is moving, is pumped inside, and you are working with very high density, power density in a short time. So mechanical effect, and then all is over. So it's a very efficient way to extract or to pre-treat biomass to be transformed. Industrial scale, so there is no limit also in the industrialization. Well, coming to the end, in the respect of the time, it's my opinion that education is not the learning of facts, but training the mind to think. So all our students, PhD, postdoc, or master student have to make their own proposal, perhaps even sometimes wrong, but we have to understand that if we are not experimenting, you can never really learn, and to make the experience that would be very useful. This is a picture of our group at the University of Torino. I also have a couple of PhD students in Moscow, at the Sechenov University. Now one of the 2 will come in Torino. And well, thanks really to Amity University and for all the organizers for this opportunity. And I hope to share experience in a very active way also in terms of collaboration. Thanks for your kind attention.
Thank you, sir. Thank you so much. Students, those who need to ask questions, they can write their questions in the chat box, and after our second speaker, we can have the question answer round. Thank you, sir, for such an enlightening session and providing us with research information how pharmaceutics industry is utilizing food processing and innovation technologies in this recent times and other technological advances in food processing. Thank you, sir. The next signatory to honor with us with his presence for today's session is Dr. Petros Revantos Venkotonis, professor at the Department of Food Science and Technology at Cornell University of Technology. He has been a national delegate in various international scientific organizations and European research programs. His research is focused on development of biorefining technologies for the separation of valuable substances from agro-food raw materials, processing byproducts, and waste using multi-step supercritical fluids, pressurized liquids, enzyme-assisted chromatographic and other extraction methods. He is an author and a co-author of over 300 publications in peer-reviewed journals and 9 book chapters. He's been a recipient of Lithuanian National Science Award winner. Today, he will be sharing his thoughts on implementation of the biorefining concepts into the food chain, paving the way to zero waste technology. Thank you, sir. Thank you for accepting our invitation.
Thank you very much, Chair, for your kind introduction. And again, good afternoon to everybody. So, and thank you very much for inviting me for this very important workshop. Now I'm trying to share my, or not. Do you see now
Yes,
Yeah.
sir, the slides are visible
Okay,
now.
okay, okay. So my presentation will be more focused, not so philosophical as Professor Kravato did, about creativity, about innovation. So I will talk about the implementation of biorefining concept into the food chain. And after some introduction, I will have selected some examples from our own research, considering biorefining of essential oil-bearing plants and berry processing products, and also some application aspects. So just first of all, I would like to show you my location. So Lithuania, it's a very small country near the Baltic Sea. You cannot even find it on the world map, but this is an enlarged fraction. So you see it is surrounded by Poland, Belarus, and Latvia, and a little piece of Russia, and the Baltic Sea. And so this is quite a big difference to your place. And I selected some refreshing pictures from January. So of course, now it's not the case. We have sunny weather, more than 30 degrees Celsius outside. And our city is the second in Lithuania city. So far as the country is not a big, so we have about 350,000 population, but it is quite old city with several universities, and we call our city student city. So, and myself, I am with the Department of Food Science and Technology from Kaunas University of Technology, not a very old one. So department established in 1950. And we are the only university level department in Lithuania, providing all degrees in food science and technology. And myself, I have a small team, which I call functional food materials. Mainly we are focusing on plant bioactive compounds and a little bit on thermal reactions in food. So some pictures of our building and our laboratory. So we have pilot scale laboratories for production of different kind of foods, and also analytical laboratories for different applications. So when we come straight to the topic, I would like to start from the terminology. So possibly many of you know, and we have definitions made by the International Energy Agency Biorefinery Task 42. And biorefinery is a facility that integrates biomass conversion processes and equipment to produce from biomass. So biorefining is actually deals with processes. And we add, of course, it encompasses many different products which can be obtained, like fuels, power, heat, and as you highlighted, value-added chemicals for food, pharmaceutical, and other application is our main field. So you can compare refinery, why is a biorefinery? So refineries using usually petroleum, and also can produce fuels, energy, and different chemicals. While biorefinery is using biomass, and also a wide range of products can be obtained by using biorefinery. So this is a very generic scheme showing the general concept of biorefinery. So in this case, we use renewable raw materials, and usually it starts from biomass fractionation, and depending on the materials, on the polarities, so we can start from the macro components like lipids, carbohydrates, proteins, and afterwards many other different processes can proceed. And I highlighted, of course, we are interested mainly in food ingredients. So biomass and biorefinery, it's the keywords are the keywords of my presentation. So I looked into the databases, and we can see that biorefining is a rapidly developing research and development. So on this slide, you can see the number of publications with the keyword search word biorefinery. So you see, it started in 1991 with the first publications. Afterwards, until 2005, very few, and now it can go to 1500s. And if you go to Science Direct, so you can see that during these years, 16,000 records, of course, includes books and research papers. And biorefining a little bit less, because mainly I'm using the term biorefining. When you restrict the search with other keywords, like for instance, aromatic plants, medicinal plants, essential oils, antioxidants, so they are not dominating. The main, of course, focus is on fuels, ethanol, and lignocellulosic materials. So, and when we think about our topic of this workshop, of course, it is very important for sustainable development in general. So biorefinery, so it includes primary refinery and industrial refinery and a lot of different raw materials. First of all, conversion into the bulky fractions, and afterwards you can continue with more complex substances and micro components like pigments, dyes, aromatic essences, flavors, enzymes, hormones, and many others. So I added to this scheme the processes and the raw materials we are dealing mainly in our laboratory. So currently we are working a lot with berry press cakes or pommers, cereal brands, and some other. And also another fraction of raw materials include aromatic, medicinal, plant, and spices. I think India, it's very famous in this area for different spices. So when you summarize the output of agromaterials in agro-food chain, so at every step you obtain the main product, and you also obtain, not always, but in the majority cases, you obtain some byproducts. For instance, like in foods processing, you obtain, of course, many crops can be consumed as fresh products, but most of them are processed into different foods, food ingredients, and again, you obtain byproducts and residues. And when they are utilized for other purposes, they are defined as byproducts, and many times they also are discarded. And in this case, they are considered as a waste. And in European Union, we have a big bureaucracy, and they defined in the directive what is a waste, what is a byproduct. So I will not read these definitions, but just short to make the story short. Waste, everything you discard to the landfills. Byproducts you use for some other purposes. So, and reduction of food waste, it's really a big global challenge. And in 2015 in Milan, there was a big expo on food, and just near the entrance was a big pavilion devoted to waste. And I made this picture with my cell phone, and you can see about 30% of global food production is lost or wasted. And still we have about 800 million people who suffer from hunger and every day. At the same time, of course, in Western civilization, we have a lot of obese and overweight people. So this is a paradox of waste. And there was a big pile of fruit and vegetable waste. Fortunately, it was not a fresh, of course, otherwise it would not be possible in summertime in Milan to enter the pavilion. It was a plastic, but it was really very, very big one. So there is a challenge. So how to deal with these byproducts and to get the best value of these byproducts. And we are working, and many teams globally are working on the recovery of high added value components from waste. And Professor Cravato also mentioned about this problem and how to deal with it. So there are, of course, many books about food waste recovery. There are many processes, including established technologies and emerging technologies for recovery of these valuable products, starting from macroscopic pretreatment, like, for instance, Professor Cravato said, mechanical separation and many other methods, and finally going to the purification using such more expensive methods like chromatography, nanofiltration, electrodialysis as established techniques, and magnetic fishing, two-phase separation, membrane ion exchange as emerging techniques. And we obtain a lot of different products which can be used, and this is a concrete example about recovery and valorization of high added value components from cheese whey. So yearly in many countries, huge amounts of whey is obtained during production of cheese, and this following the scheme, you can start from macroscopic pretreatment and to obtain casein, whey cream, and afterwards you can go to more sophisticated products like glycoproteins, whey protein concentrate, which of course need some input, financial inputs, and of course technological upscaling. So from whey, there are many established technologies which provide a lot of different products like whey protein concentrate, lactoferrin, lactose, and whey protein concentrates, possibly you know, are very valued by the bodybuilders because this is a protein, and of course you can build a lean body mass. So I selected some examples from the literature. I will not comment too much. I will come to our own example. So for instance, this is also established technology for empty fruit bunches in palm oil processing, and quite a bit of biomaterials you can obtain by using byproducts in palm oil production. So this is new products from cocoa shells, cocoa bean shells. So cocoa beans, we know, it's a main product for production of chocolate, and still quite a bit of cocoa bean shells are generated during cleaning of cocoa beans. And in this study, they declare a lot of different products like extracts, adhesion test glue, dyes, antifungal concentrates, the products with biocidal capacity, plant growth inhibitors, and usually you can obtain natural antioxidants with different antioxidant power. So orange peels, of course, is a huge amounts of byproducts are obtained, and in many cases wasted. And in this case, the production of different products from orange peel. Of course, essential oils have been produced already for many years, usually by pressing. Still after pressing essential oils, solid residue can be further fermented and used for industrial enzyme, single cell proteins, ethanol, methane, and heat, and other products. So we had several years ago cost actions. This is the specific program in the European Union for cooperation in science and technology. And they usually give funds for the cooperation between the teams which are working in the same topic. This was the logo of our action. It was coordinated from York University, and they, for instance, developed orange peel exploitation company. So you see abbreviation is a little bit dubious. So, and in this case, they can produce a lot of different materials. So in literature, nowadays you can find many reviews about biorefining of byproducts, particularly for recovery of natural antioxidants. I will not comment too much, but they include olive oil wastewater, sea buckthorn berries, mango peel, white grape pomace, rice bran, palm fatty acid distillate, wheat germ, and many other products. And in this case, the researchers were focusing on recovery of natural antioxidants, some famous structures like gamma-oryzanol from rice bran, fluorescein from apples, orioropin from olives, hydroxytyrosol also from olives. Chlorogenic acid is present in many different fruits and vegetables, like ferulic acid in cereals, avenanthramides, mainly in oats, and squalene, for instance, also in the products like amaranth. So when we come to the research topics we are dealing with in my team, so we are dealing with different biomaterials, as I mentioned, aromatic medicinal plants, spices, berries, their byproducts, and cereals, pseudo cereals, a little bit with other materials as well, like spent coffee. Different processes, including traditional extraction, fractionation, supercritical fluid, subcritical water extraction, and some further processing like encapsulation. Yes, we do also apply ultrasound extraction, but of course not in a so sophisticated equipment and ways as we could see in Professor Cravato lecture. So we mainly focusing on supercritical fluids and different products, phytochemicals, essential oils, antioxidants, antimicrobials, other bioactive compounds, and also as food science department, food technology department, we also try to apply these recovered products in different foods. So in general, all people who work with the plants consider the plant as a kind of factories of natural chemicals, we call phytochemicals. And of course, they biosynthesize these chemicals for themselves genetically, but of course, these phytochemicals are valuable bioactive compounds for human health, for natural food additives, and of course, in India, a very long history about the use of different medicinal plants, spices for different health applications as well. So what we can get from aromatic plants? We can get antioxidants, antimicrobial agents, despite essential oils, for instance, and these components can be used as ingredients for functional foods, nutraceuticals, pharmaceuticals, and cosmetics. So it's an interesting fact I have found somewhere that there are more than 20,000 edible plant species in the world. However, less than 20 species provide 90% of plant origin foods. Of course, rice, wheat, corn will stay among these staple food species. However, a great number of species are used at very limited amount. Some plants are very poorly studied, and it inspires search of new sources of valuable compounds. So when we look into the botanical, so I categorize it into two groups. Some of them, they accumulate quite a lot of essential oil, usually more than 0.1%. While some plants, they do not biosynthesize essential oils or just negligible amounts. However, they do produce different other valuable components like higher terpenoids, flavonoids, phenolic acids, tannins, saponins, and so on. So, and the first example I will show on biorefining of essential oil containing plants. So these are the list of the richest sources of essential oils. Sometimes it can go up to 10% from cardamom, but most of the leafy plants, particularly, they accumulate 1%, less than 2%. And this is a traditional extraction processing of herbs, spices, and aromatic plants. So a very widely used process is a steam hydrodistillation, just to get essential oil. For citrus expression is used, and also different solvent extraction methods are used to obtain other type of products. So usually these are quite energy consuming, and when hazardous solvents are used for extraction, of course, the methods are not friendly for food applications and from the environmental protection point of view. So when you look into traditional methods, so this is still very widely used, and I think will be widely used. So we get 0.533% of something which is used after this process, essential oil. And in this case, up to 99.5% is a residue, byproduct, which very often just discarded. And currently in the world, there are approximately 100 species which are used for essential oil extraction. The value, of course, very different. There are very important commercially essential oils like orange, cornment, eucalyptus, and there are, of course, minor the plants which produce very little amount of essential oils just because there is no demand. So we developed a fractionation of botanicals for their biorefinery by refining using conventional methods. So of course, first of all, hydrodistillation, you get essential oils and you get a big amount of residue. So we can call it deodorized dried plant material because flavoring volatiles have been removed. So in this case, we have solid residue and water residue because hydrodistillation is performed using steam or water, so kind of soup. And usually after evaporation to dryness, and we obtain dried deodorized water extract. So using simple commercially available spray drying, freeze drying techniques. And usually contains water-soluble substances, while solid residue can be further extracted with lower polarity solvent like acetone, filtrated, evaporated, and we can obtain a fraction with lower polarity substances. So at the end, what we get the yields of extracts from 5 to 15% of dry weight. So including essential oil, so we can go up to 35%. So not bad compared to very low amount of essential oil. Still, residue 65–70%. Most lignocellulosic substances, some proteins, can be further biorefined, used for fuel or something else. So when we analyze this expert, this is one example from Calamintha grandiflora. So we published it in Food Chemistry. So we can get about up to 200 milligrams of polyphenolic compounds from 1 gram of residue. So quite a bit, 18% and more. That of course depends on the solvent selected, on the methods of drying, and usually these substances they can demonstrate quite strong antioxidant capacity, like in this case, in Trolox equivalent antioxidant capacity. Then you look chromatographically, so we can find very strong antioxidants like rosmarinic acid. So in this case, we have a very interesting method when we can measure by using ultraviolet detector. We can detect the compounds, and afterwards we can move to the radical scavenging loop. And when the compound scavenges radicals, so we get negative peak. So from this chromatogram, we can screen many compounds and to know which compounds are strong radical scavenging. Like this is ethanolic extract, this is freeze-dried water extract, in this case different compounds. For instance, like salvianolic acid also was very strong radical scavenger. So we can recover. This is another example, so maybe I will not stop on that. Also, we can get, you see, about 18-20% of polyphenolics from the residue. So the details of these research is published in different journals. This was a very simple explanation of very traditional methods everybody can use in the laboratory. It doesn't need sophisticated and expensive equipment. But we nowadays more moving to more innovative, more effective from some point of view methods, like, and we in our laboratory mainly focusing on high pressure applications. So, and during high treatment of biomass with high pressure, hydrolysis and extraction, for instance, with supercritical fluids, it is possible to recover very efficiently lipophilic compounds with subcritical or hot water, hemicelluloses, monomer soluble lignin, and then you would add enzymes, so we can get another fraction, and so on and so forth. I will give you some examples. And in this case, the sequential use of fixed backed reactor in high pressure biorefinery application, we can obtain several fractions. So, for instance, first process this extraction with supercritical carbon dioxide, we get fats. Afterwards, we can continue with subcritical water. You see, 180 degrees at different pressure. We can extract proteins. Afterwards, when we add some ethanol, we can obtain hemicellulose, lignin, glucose, and water with enzymes. So we can separate lignin. Of course, separation is not doesn't provide very pure extract, but still you can get the fractions with the high concentrations of these substances. So as I said, now we do work a lot with fruits and berries, particularly berries. And everybody knows that berries and fruits, vegetables are considered as a healthy products. And there is even a slogan, 5 a day, your way to health. Many fruits and vegetables are highly perishable, and they processed into different products. And usually they contain such bioactive compounds like vitamins, polyphenolic antioxidants, dietary fibers, and others. So the problem, again, significant losses. I have found this information which shows the losses during processing and consumption of fruit and vegetables in different parts of the world. So you see in the developed, highly developed countries, Europe, North America, quite high losses during agricultural processing, harvesting, and very high losses during consumption. While in less developed countries, underdeveloped, so the main part of the losses are in the processing phase, not so much in consumption. So you see these developed countries really losing a lot of people during consumption. So it's a little bit more detailed, showing fruit and vegetable loss and waste at different phases. And I found this nice review which shows how many publications were published, and really very the variation of the data is quite big, depending, of course, on the fruits, vegetables, and the countries. So now I come to our work on berry pomaces. So it's very simple. When you produce juice, so you just press juice, you can pack it, and you can sell it. And quite a lot of press cake is a residue. We called it a pomace. And usually it can contain approximately 30% of dry solids. And they sometimes just discard it as a waste, or compost it or use for animal feeding. So this I made the picture in some small company pressing juices. So it's a simple equipment. Nowadays we have a lot of these small companies located near the farms. So it's very easy. You can bring not very big amounts of berries, let's say kilograms, and to produce juice. So we are working mainly with northern berries. So I put it into that's because of course many of these berries can be grown everywhere, like raspberries, strawberries, but still we have very specific berries which are not very widely processed in the other parts of the world. So therefore they can sometimes call northern berries. So you will not find their grapes. So we are not interfering with Mediterranean countries and other countries which grow a lot of grapes and process. In Lithuania, some people do grow grapes, but just for fun. So berries possibly are the richest sources of different phenolic antioxidants. Depending on berry species, different type of phenolic compounds are accumulated. Like for instance, sea buckthorn is a very rich in flavonols. Crowberry, cranberry, like raspberries, for instance, are very rich in ellagic acid derivatives, like ellagic acid, ellagitannins, and so forth and so on. So you can see the distribution of different type of phenolics is very different. However, when you look into the literature, you will find quite many publications about health benefits of these compounds. So therefore, eating berries is considered as a healthy way of, and I selected some examples, chokeberries. These are very dark berries. They are not eaten as a fresh because the taste is not very good, but widely used for pressing juice, admixing juice to other juice, and for producing jams and other products. But when you look into the berries, juice, and pomace, you will see that pomace sometimes richer in procyanidins and other phenolic compounds, and antioxidant capacity is similar in the whole berries, in the juice, and the pomace. So when we discard the pomace, so we are losing all these phytochemicals. So this is more detailed study. So you will see that pomace also contain a lot of different phenolic compounds. Some groups, the content of some groups is much higher compared to the whole berries and juice. And so pomace landfills, of course, cause environmental pollution problems because it's biomaterial, not so easy to digest. So we are working on increasing the effectiveness of utilization of berry pomaces. Not that easy because they are quite complex, heterogeneous materials. They consist of exocarp, skins, seeds, and flesh residues, endocarp. And all these parts are different in composition. So in our biorefining scheme, we start with extraction of lipophilic compounds. And of course, you can do it by using hexane, petroleum ether, but it's not environmentally friendly. And of course, nowadays, consumers, they don't like when some hazardous chemicals were involved in the processing. So in this case, we do a lot of work with supercritical food extraction, starting modeling and lab scale extractors, and afterwards upscaling in a pilot scale. We have 10-liter extractor. So for those who are not familiar with this method, so in this case, every gas or liquid can be heated and compressed until the so-called supercritical point. And for instance, for carbon dioxide, which is very widely used because it's non-flammable, cheap, and critical point is not very high, about a little bit more than 7 megapascals and about 31 degrees Celsius. So reasonable temperature and pressure for commercial applications. However, the density and diffusivity of the solvent, supercritical solvent, so you can get the solvent at different pressure and temperature, depends very much, particularly on pressure and temperature, and solubilization properties also. So therefore, in this case, you can have some selectivity by changing pressure and temperature, but quite a bit of modeling studies are required for this, for different materials to establish the ideal point, you can say, when you get the highest, let's say, extract yield. Like in this case, you see, because the dependence on temperature and pressure is opposite. The increasing pressure increases density, while increasing temperature increases diffusivity, however, decreases the density of the solvent. So in this case, you have to do this modeling and afterwards to see if the theoretical model fits to the experimental results. And in this case, for instance, from raspberries, we get up to 15% of extract yield at about 30 megapascals, 45 degrees temperature. Of course, we can describe by second order polynomial equation, but it's not so important. So we do quite a lot of optimization just to determine pressure, temperature, sometimes also particle size and the flow rate, the time to get the best yield or the best recovery of some particular compound. So you can do this central composite design based response surface methodology for different parameters. So, and you see this is from cranberry. So very nice color berries. This is ground pomace. So extraction. So you can get yellow color stuff, about 12%. The residue is still red. So we know that something, pigments are still left in the residue, not extracted. Depending on the berry pomace species, you can get very different amount of extracts, let's say from only 3-5% from chokeberry or aronia and up to 20% from some other berries. So extraction kinetic studies are particularly important for upscaling because sometimes you get very long time by these modeling studies. But when you do the upscaling studies, you can see that the most of the soluble substances are extracted very fastly, 30-60 minutes. So therefore, of course, when you want to commercialize, maybe to sacrifice these 2-3% of residual substances and to use a much shorter extraction time. And in this case, of course, you win time and you win from the economic point of view. So as I said, you can get from 3% to 20% of lipophilic substances. So these are prototypes of the products we made from different berries. And of course, we have detailed examination results of their composition. They are rich in bioactive compounds, polyunsaturated fatty acids, particularly. You see, for instance, mainly polyunsaturated fatty acids prevail in these extracts like linoleic, alpha-linolenic, omega-3, oleic acids, and which are considered as a healthy fats. So, and what you can do, they also contain microcomponents like vitamin E, tocopherols, phytosterols, carotenoids, some of them squalene, big range of bioactives. So you can just encapsulate these products and sell as nutraceuticals. Of course, they should be standardized depending on the needs. So, and EFSA, European Food Safety Authority, approved health claims for these acids. So, and after defatting, removing lipophilic part, I continue with cranberry pomace. So we can apply subcritical water or pressurized liquid extraction. Well, again, with green solvents, ethanol, water, and again, you have to do some modeling, and finally, you get very nice color extract with high concentration of polyphenols, antioxidants, and the residue is, you see, it's already almost colorless. It mainly contains dietary fiber and proteins. Again, quite good substances for food. So this is a summary of extraction of raspberry pomace. So after grinding, you get about 15% lipids. After high pressure extraction, you can get another 24% of solubles. And afterwards, we can apply other type of extraction like enzyme assisted extraction Or it depends. It depends. You can have a very big choice. You can immediately use the products obtained, or you can go further to get more purified products. And again, during high pressure extraction, you can get, you see, up to 64% of solubles. So, and finally, the residue already could be 30, 40, 50 maybe percent. So I said that the health benefits of berries are evident, and therefore application is also evident. So it can be applied for producing functional foods. So this is the simplified scheme of production of functional foods. So one of the main methods is just to add one or more components which provide specific functions to ordinary foods. So there are other methods, but this is the main one. And we try to add these extracts or other products we obtain to different foods. So in this case, we used purees, fruit purees, and you see by increasing the additive range, so most of the characteristics increasing many times, like ellagic acid, which is anti-cancer agent. And of course, in this case, we have to do sensory evaluation. And in this case, we found that 1.6% or higher additive concentration are not good for consumption because it makes some problems for taste. However, even lower amount of additives already increase severely the concentration of different bioactives. So we even tried to use it in meat products. In this case, to look at the effects of meat oxidation. So, and when we use ethanolic extract, so you see oxidation followed by the malondialdehyde concentration, which is oxidation product in meat. So it almost inhibited compared to no additives. While supercritical extracts, they increase oxidation. Very clear reason, because supercritical extracts contain sensitive to oxidation fatty acids. So together with partners in biomedical schools, we also testing the effect of these products against, let's say, cancer cells. And we see that at some concentration, they can inhibit proliferation of different cancer cells. And in this case, we try to give some, of course, very preliminary evidence. May berry pomace phytochemicals mitigate carcinogenicity of processed meat? Possibly you heard that some years ago, the International Agency of Research on Cancer included processed meat product into the first group of carcinogenic substances. So it means that they cause cancer, while red meat products were included into the second category, probably causes cancer. So in this case, meat producers, they are very interested to find some compounds, some natural additives, which could mitigate these harmful processes. So, and we, of course, as I said, this is very preliminary, because to prove in vivo studies should be done. So, and finally, also we do use frequently enzyme-assisted extraction. In this case, we have to optimize quite a few parameters, like enzyme substrate ratio and the amount of enzyme, temperature, time, pH. So therefore, we get a lot of these graphs, because the dependence of these variables could be opposite. On the contrary, we can work. So therefore, not that easy to find this magic point. But by using this technique, we can get another portion of extract. So, and for instance, this is the biorefining scheme for black currants. Now we in the commercialization process already with the company from north of Lithuania. In Lithuania, black currants among the most important berries. And actually, we are seeking green zero waste technology. No hazardous solvents, so everything environmentally friendly, food friendly, and of course to use everything. So, and as I showed you, the extracts, they can find many applications. The residues, they can be further treated by enzymes. Of course, if you can see that the higher value products can be obtained, because every step includes investments into the equipment, into the resources. However, the price of processed products is also increasing. So therefore, these technological upscaling and particularly economic considerations should be taken into account during upscaling of the products. So as I said, these pomaces are quite heterogeneous materials. So it is possible as a first step mechanically to separate them. And afterwards, you can get the bigger range of the product, because the skins, the composition of skins and seeds is completely different. It depends. So on the demand of industry, market demand, so we can develop many different products. So this is the summarizing scheme of our biorefining processes. So it includes many different processing, like simple ones, drying, mechanical separation could be done, could be not done, and afterwards several consecutive extraction processing. And used during this sequential extraction with different polarity solvent. CO2 is non-polar, so you can get product, you get residue. You can a product, you can get residue, product, residue, and you can go further with chromatographic separation, and you can get quite many different products. However, as I said, it depends on the demand, and it depends on the value, and it depends whether the company is able to invest. Of course, if it's very profitable, they can do it. So, I maybe will not comment too much because the time is expiring. We can do further separation by changing pressure and temperature into the separators. So we can do extraction to get the highest yield. Afterwards, we can change temperature and pressure, and some fraction already becomes insoluble or little soluble. And we can separate by this method into the different fractions, and you can get rich fractions, for instance, in tocopherols, 3-10 times compared to the crude extract. You can get the richer fractions in carotenoids. So we manage by preliminary research to get 2.5 richer fractions in carotenoids. You can get richer fractions in antioxidants. We managed to get 5, 6, 7 times richer fractions. So, and most of these studies have been published both on fractionations and applications, and in different journals. And we do have cooperations with different institutions. And for instance, tomorrow I fly to France, to Avignon, where my previous master student from India was very smart, Harish Kartekian. After getting master in my group, he was enrolled as a PhD student in Avignon University, together with Professor Sharma. I'm sure that Professor Cravato, he knows him. He is also doing a lot in microwave, ultrasound extractions. So, and the day after tomorrow, Harish will be defending thesis, and I will be in the jury. So, and I wrote book chapter particularly on valorization of berry processing byproducts last year. And I would like to thank you very much for listening. This is the names of my team. Unfortunately, I haven't included a picture. And also, I would like to invite students from India to come to our university for bachelor studies. We have food science and technology, master studies, 2 years. We have food technology, food science and technology, and finally, we do also have PhD studies. And if somebody would like to work with me in this topic, on this similar topic, so very welcome. So thanks a lot again. I think it's time to finish.
Thank you, sir, for such an enlightening session and giving us such good information. We are fortunate to have our Vice Chancellor Madam with us for today's session. I feel delighted to welcome our Honorable Vice Chancellor Madam, Professor Balwinder Shukla. With a strategic mindset and creative thinking ability, she has been one of the key team members, spearheading and instrumental in the exponential growth of Amity groups engaged in higher education. Ma'am has vast research experience. Ma'am has been a recipient of various prestigious awards and honors such as Distinguished Academician and Outstanding Administrator. On behalf of AIFT, I welcome you, ma'am, with greatest reverence and highest admiration. Thank you, ma'am.
Yes, Dr. Sunil.
Yes, sir.
Yes. It gives me a great pleasure to extend a very warm welcome personally and on behalf of Amity Institute of Food Technology to our respected Honorable Vice Chancellor, Madam, Professor Dr. Balwinder Shukla. How grateful we are, Madam, Vice Chancellor, who is mastermind behind this mega and unique national workshop, is with us. Madam, with all your guidance and encouragement, we would able to organize this workshop with our whole heart. We welcome you, Madam. Madam, please.
Yep. Thank you very much, Dr. Modi. Sorry, I could not attend your inaugural session in the morning. You know that today we had the 3 faculty development program and 6 value addition workshop for the students. But I wanted to be part of your program, and I said I will join towards the end. And we had the University Research Council meeting also today. So many things, but I first of all I would like to congratulate you and your entire team of Amity School of Food Technology who have organized this wonderful workshop on innovations and sustainability in food processing. I was listening to the speaker, the last speaker, Professor Rimantas Vensukutonis, and the Professor Giancarlo Devoto, and you have arranged a wonderful speakers from across the globe for this very, very important topic. As we all know, the food scientists need to work together with the agriculturist or the nutritionist or civil society and the governments to develop an integrated approach to feed a growing population sustainably, because some places you will find the food is in abundance, but other places the food is in shortage. So also that if you take the food field to fork, there's so much pilferage happens, so much the food is lost, and some because of the lifespan of the food, some because of the other aspects. Therefore, how to enhance the shelf life of the food, how we can enhance. So food processing is very, very important element. Because the food processing, which is the important link between the production and the consumption when we talk about the food value chain. And therefore, the food production technologies in today's global environment are very important. How do we enhance the skills and competencies of the students in the on the food technology, food processing? What are the latest technologies are there for the food processing? How the food can be processed, stored, and conserved for the longer shelf life, so that it is available to the population for a longer period. And a lot of if the food processing is not taken care, I think the dream of that every human being having the sustainable diet will not be fulfilled. So therefore, the food processing is extremely important. I was listening to the speakers, and I find that you are going to the participants are going to learn many new technologies in the food processing, and And in India itself, we are seeing that the food processing sector is on a high growth and high profit, and therefore it is contributing in big way in the world food trade every year. And um, we know the Indian food industry is the fifth largest industry. How we can become the top industry depends on the how we are able to develop the technologies and the skill set of the employers, so which um, can grow the food industry can grow, maybe around 15% or something like that. Though we are the agri dominated country, but the agriculture does not contribute to the overall GDP of the economy as much as it should be contributing, where the services sector are in big way are contributing to the GDP of the country. So therefore, lot need to be done by the agriculture sector as well as the food processing sector, if we really want to enhance our country's GDP and also become the biggest exporter of the food produce. And so therefore, I would like to congratulate Dr. Modi, you and your team for organizing a workshop which is going to address the issues of sustainability in the food processing, understanding the strategies for food safety and sustainability, innovation in food processing and development in food quality and sustainability, and also for the opportunity for the entrepreneurs in the food sector, because the agri-based business need to grow, food processing industry needs to come in the private sector, and the new entrepreneurs need to take this initiative. We are really looking for the growth of this sector and to become the biggest exporter of the food produce. So I'm sure all the participants who are attending this workshop will be learning a great deal out of this workshop. And I would request, I'm sure that you are going to conduct the various quiz and other assessments
Yes.
to ascertain the attainment of the learning outcome of the students from this workshop, and before providing the certificates. I'm very impressed by the list of the speakers which you have able to win over for this workshop. So my request is how you and your faculty can jointly discuss with these great researchers and scientists from across the country, and we do maybe the collaborative work in the area of research or in academics or other area or training and consultancy or joint projects. So I would like to see at the end of the workshop what outcome we are, in addition to the student learning and the skill development, what is going to be the short-term outcome and what is going to be the long-term outcome. And I would also be very keen to understand that whose these contacts are there, and so that the person can build that contact and the team of the faculty can work together, and joint search and collaboration we can have. I would like to especially thank today's speaker, the Professor Rimantas from the Kaunas University of Technology, Lithuania, and also Professor Giancarlo Cravato of the Department Drug Science and Technology from University of Turin, Italy, and and tomorrow also I can see the very impressive list of speakers are from different countries: Iran, Iraq, India, and USA. And in the day after tomorrow you have Indian speakers also. You have so this is wonderful resources. So the students are going to get, the participants are going to get the knowledge from the across the globe. So what are the best practices? What are the trends? What are the technologies? I think having this global exposure will put the students on the higher pedestal compared to their peer group in the program. So with this, once again, I congratulate Dr. Modi and the whole team for a very wonderful workshop, realizing our honorable founder president's vision of developing the future talent as per the industry requirement. At the same time, also building the global relationships and collaborating. So thank you very much and wish you all the best.
Thank you, madam. Thank you. Thank you, madam. We are honored to have you with us. All your blessings and your encouraging words for my team. Definitely, will whatever you have advised, we'll follow it up. Thank you, madam. Thank you very much.
Thank you, ma'am, for your words.
Yes,
Now
over to
the
Dr.
session. Yes, sir. Now the session is open for the questions. Please, participants, you can write the questions in the chat box so that we can take up one by one.
There is one question. From Mr. Vasu, and he wants to know about KET's key enabling technologies. KET's key enabling technologies. I think Vasu, it is about yes.
Yeah.
Yes.
Well,
Sir.
I think,
Yeah.
I mentioned, see, the CAT, key enabling technologies, of course, are not only referred to this specific field, of course, are in a general application that enable to save energy, to save time, to improve quality, and of course, all can be, so there are many opportunities in field. What I didn't mention before, having strong collaboration with the food industry as well as pharmaceutical industry, is that the investment done in CAT by food technologies is higher than the investment of pharma industry. So pharma industry, of course, is investing a lot in the research, but as regard technology, considering the volume of food industry, this has a major impact. We could consider several aspects. Rapidly, just only to don't waste time, the cold pasteurization is one of the examples. So how to inactivate microorganisms thanks to cavitation, thanks to pulsed electric field, all this technology, including also hydrodynamic cavitation, either with orifices or with venturi tubes, or rotor stator system. There are several technologies that, for example, can be applied for liquid. We studied with milk. We published also a few years ago, also an example, but can be applied for fruit juices. So in order to have fresh milk or fresh juice, but with longer shelf life. This is, of course, it has to be preserved, cooled, clearly, because it's not, but microorganisms tend to this technology, typically is the cavitation, enable to reduce or to inactivate more than 95% of the microorganisms present that cannot multiply, cannot grow. So, but well, present, of course, but well, it can offer longer shelf life. For milk, I think is really important because milk is very rapidly, and also for the digestibility, because this treatment also reduces the fat droplet in a very, very little size, so it's much more digestible. Just to give an example of key enabling technologies for food application. But well, there are many, many possible examples, and we'll be pleased to eventually discuss with more time. Thank you.
Thank you, sir. Thank you. Yes, Dr. Sunan, is there any other question?
No, ma'am. I think this is the only question, Vasu, from Vasu.
Extremely
yes.
sorry, ma'am. Ma'am, please check the chat box. There is one more question from Shrestha.
Okay.
Yes, please.
Yeah,
No,
Ma'am, can you read the question
Yeah,
because
yeah, I'll read the question. What are the effects of ultrasonic packaging on food products? Yes.
I mean, in packaging. Well, in packaging is the welding is very rapid, and having no heat, you have the advantage that you preserve any degradation due by heat. You can imagine also candies or snacks, and also Tetra Pak can be closed. Even due to the efficiency, you can imagine, even Parashut, for law, for regulation, they need also to be also fixed with a nail and so on. But well, the main connection and welding of all the part of the Parashut are done in a very efficient way with the ultrasonic. So ultrasonic can put together the two surfaces, and due to the vibration, they melt each other, but the heating is just concentrated on the rime that are in connection. So it's very fast and very efficient. But with ultrasonic, and also you can also pack, for instance, the cereal bar. You can have a number of applications apart from emulsification. Very, very important for the application is the crystallization. So filtering, sieving, and crystallization that can have a huge advantage with ultrasound. So the filtration, very simple filtration, is instantaneous, is because your sieve is moved 20,000 times per second, and so your powder is immediately filtered, so rapidly, so make us sieved. And crystallization, sugar can be, of course, also drugs. There are many products that can be very efficiently crystallized in flow mode with sono crystallization. That is of big interest. Well,
thank you, sir. Thank you. This is really very interesting, a new, topic. Yes, there is.
Really, I'm sorry, in India, you have the best expert in hydrodynamic cavitation and also ultrasound which have also, we have strictly contact and collaboration. So your country is giving a big contribution in this field. I don't know which is the connection with the industry. From my side, I'm working a lot with the industry, so I see then the real application in big size. This morning we were discussing before in an application in which the production is 10 ton per hour. So 10 ton per hour. So it's an application in food industry. So it's totally different concept when you are working with gram or in the lab milligram. 10 ton processing per hour is a totally different. So in terms of energy, in terms of device, engineering. So sometimes there is a too big gap in between. So what is the size in the lab and the size really in the lab, what the industry need. Thank you.
Thank you, sir. Now, this is a question to Professor Rimantas, and it is from Dr. Tarun, and he's asking, keeping circular economy in mind, what about the solid waste or byproducts left after all processing or valorization? What about the solid waste or byproducts left after all processing or valorization? Do we go for its complete utilization and lower environmental effect? Do we have Professor Rimantas with us?
Yeah, he's there
Yeah.
in the session.
Yes. Yes. There is another question. Yes, there are two more questions.
Yeah,
And
please read.
yeah, this is about this is from Chandrakala. So she wants to ask to throw some light on utilization of fruit byproducts like pomace for aroma compounds. Pomace for aroma compounds.
Professor Remantas. Dr. Renu, you just go through with the questions because Dr. Cravato is there. Yeah. Any questions for him?
Yeah, well,
Just now.
of course, flavoring in general are of high importance, and the impact in the quality of the product is amazing. We were working with a startup in the development of aroma concentrator. That means when you are working typically with the sterilization of fruit juices, with the heat, you are losing normally the biggest part of the best aromas and flavoring that is going with the vapor. With this kind of new generation of aroma concentrator, you can make with a multiple effect a concentration of the best flavoring that remain on the upper part and water in the bottom. In the end, you can reinsert in your cool and of course pasteurized fruit juice the aroma, and so the difference is amazing in terms of quality. So in general, also from wastes with the treatment by heating and then cooling and to concentrate of course the volatiles is really important. Of course, it depends which was the previous treatment. You have to, if you in some way you heat, you have to immediately condense and keep the separation of the volatiles. We have big experience in the preparation of essential oil and distillate with microwave assisted system, also in big scale, as you see, with several kilograms, and it's much faster because you heat directly the bulk, you don't heat the container. Is a fast heating with microwave and fast cooling. So the quality of the essential oil and the distilled water is of course much better. So there are several technologies also in this direction. Thank you.
Yes, thank you. Thank you, sir. Thank you. Yes, Dr. Sunil.
I think, ma'am, we are done with questions. Let me see. Okay, so now we come towards the end of today's inaugural session, and I would like to ask Dr. Renu Deepak Khedkar to please say the vote of thanks. Over to you, ma'am. Thank you.
Okay. Thank you, Dr. Sunil. So I have the honor to propose a vote of thanks for the inaugural session of the 8-day workshop on innovations and sustainability in food processing. Our heartfelt thanks first to our distinguished guest of honor, Professor Dr. Giancarlo Cravato, and keynote speaker, Professor Dr. Rimantas Venskatonis, for accepting our invitation at such a short notice and enlightening us with their knowledgeable presentations. Thank you, Professor Cravato and Professor Rimantas, for your elaborative presentations and with your research, enlightening us with your research. We look forward to collaborative research activities with you, sir. We are highly grateful to our Honorable Founder President, Dr. Ashok K. Chauhan, sir, for blessing us. We are also under his, we are working towards his vision. So his blessings are very, very important, and we are very grateful to, have them. We are also thankful to Honorable Chancellor, Dr. Atul Chauhan, sir, and for his motivation, and of course, Honorable Vice Chancellor, Madam, for her guidance during organizing the workshop. We are also thankful to Madam for gracing this, event and blessing us. We are thankful to Dr. Silva Murthy sir and Dr. Nutan Kaushik ma'am for their guidance and support at all levels. We always get it, ma'am and sir. Thank you so much.